right. So now we're going to do kind of the same thing, but a little bit of a twist on the equality. Okay. So let's just say we know that absolute value of -3 is 3, and absolute value of +3 is 3. Okay. We can also say that the absolute value of -3 is equal to the absolute value of +3. Okay. So we know actually 3 things. We know this is true. We know absolute value of 3 equals absolute value of 3. And we know absolute value of -3 equals absolute value of -3. Because all of those equal 3. Okay. So that means no matter what's in here, positive or negative, it'll still equal that. And instead of an equal sign, we'll just make that an arrow. Okay, because what we're mainly worried about are those two, because it gives us our next general idea. So in general, you know, if you have some absolute value of x that's equal some absolute value of y, that means x equals y or x equals -y. Okay, because remember, they can both be the same, so x can equal y, or x can equal -y or -y, whichever one you want to flip it around. So they can have the same signs or opposite signs, and it would still be true. Okay, so it's kind of a similar idea, but just a slightly different approach, and you'll see what I mean by slightly different. Okay. So let's say, for example, you wanted to solve the absolute value of 5x plus 3 equals the absolute value of 3x plus 5. Okay, so here's a little bit different because now you have an absolute value on both sides. That's why it's just slightly different, but the idea is pretty much the same. Okay, so if we remembered, not remembered, I said remembered, but remember, the absolute value of x equals absolute value of y means that x can equal y or x can equal -y. So if this is your x, well, we'll call it x, and this is your y, absolute value of 5x plus 3 equals, make that a little taller so it doesn't look like a 1, there we go, absolute value of 3x plus 5 means 5x plus 3 can equal 3x plus 5, or 5x plus 3 can equal -3x plus 5. Okay. So the two values inside the absolute values can be equal, or they can have opposite signs. Okay. So that's set up, and we do the exact same thing, we just solve for x. Okay, so now that we have those, we just solve both for x. Okay, so if we solved our 5x plus 3 equals 3x plus 5, and we subtract 3x from both sides, that cancels out. So you have 5x minus 3x, which is 2x plus 3 equals 5. And now we just subtract our 3 from both sides. And that gives us 2x equals 2. Divide both sides by 2, and we have our x equals 1. Okay, so that's our first solution. block that off a little bit. Our second solution, 5x plus 3 equals negative 3x plus 5. Okay, and don't forget your parentheses because it's the negative of that entire binomial. Okay, so now you just distribute that negative. So you have 5x plus 3 equals negative 3x minus 5. Okay, so now we just add 3x to both sides. And that gives you 5x plus 3x is 8x plus 3 equals negative 5. Subtract 3 from both sides. It gives you 8x equals negative 5 minus 3 is negative 8. Oh, wait. Oh, maybe it seems like I'm missing something. Yep. Negative 8. There we go. Alright, so that means that x is equal to negative 1. Okay, so all we have to do is check. Wait, might be able to check it on this page. Might have enough room. Okay, so if we check it, absolute value of 5x plus 3 equals the absolute value of 3x plus 5. So if we let x equals 1, that gives us the absolute value of 5 times 1 plus 3 equals the absolute value of 3 times 1 plus 5. Okay, so 5 plus 3 is 8. So absolute value of 8 equals 3 plus 5 is absolute value of 8. Okay, so we know that one's true. All right, so what if we let x equal negative 1? Okay, so we know that 5 times negative 1 plus 3 equals 3 times negative 1 plus 5. Okay, 5 times negative 1, negative 5. Move that up some. So absolute value of negative 5 plus 3 equals the absolute value of negative 3 plus 5. And that gives us absolute value of negative 2 equals the absolute value of 2, which is true, because they're both equal to 2. All right, so any questions on that one? All right. I'll leave that up for a few more seconds. All right. Okay. So now we're going to solve inequalities. Okay, so this inequalities of the form absolute value of x is less than k. Okay, so these also work for less than or equal to, or absolute value of x is less than or equal to k. Same method for both. All right, so we know that the absolute value of x equals 5 just means the distance from 0. Okay, that's why it can be 5 or negative 5. But what if we have absolute value of x is less than 5? That just means the distance from 0 is less than 5. Okay, so if we had to look up on a number line, and this was 0, and we had 1, 2, 3, clean that up, 4, 5, and -1, -2, -3, -4, and -5, and we started at 0, if we had the absolute value of x is less than 5, this would be true. Every number here would be true. Absolute value of 3 is less than 5. Absolute value of 4 is less than 5. Absolute value of 2, absolute value of 1, absolute value of 1.5. All of those are less than 5. But the same thing's true in the other direction, because everything here would also be true. But in this case, we're not counting 5, because it wouldn't be true for 5. Since the absolute value of 5 is not less than 5, it actually is 5. Okay, so the absolute value of x is less than 5 for all of those negative values also. Absolute value of -3 is 3. 3 is less than 5. Absolute value of -4 is 4. 4 is less than 5. So for either positive or negative, they'll all be true. Okay. So any value, let me see, between here and here, any value here is less than 5 units from 0. Okay. So just because of the fact that we know that every value in here would make that true, we can honestly say that the absolute value of x is less than 5 means that x is greater than -5, which everything greater than that one would make it true. Or, I guess you could say or. Not really or, it's and. And x is less than 5. Okay, so if it's less than 5 and greater than -5, it goes right in between there. Okay, so that idea gives us once again, our general idea. Okay, so in general, absolute value of x is less than k means that x is greater than -k and x is less than k. Okay. You can also rewrite that as -k is less than x is less than k. Bless you. Okay. Same thing for less than or equal to. So we'll put that there. So absolute value of x is less than or equal to k means that x is less than or equal to -k and x is less than or equal to k. And you can also rewrite this one pretty much the same way. Where -k is less than or equal to x, less than or equal to k. All right, any questions on that so far? Okay, so the same way we use the equal to formula, we're going to use these two formulas based on whether it's less than or equal to. right. Let's start off with an example. Straighten that up a little. There we go. Okay, so for example, let's say we wanted to solve the absolute value of 2x minus 3 is less than 9. And graph it. And graph the solution set. Okay, so we know we have a less than, which means we're going to use the method for less than. Okay, which means you have to remember absolute value of x is less than k means that x is greater than negative k and x is less than k. Okay, so if we wanted to find the absolute value of 2x minus 3 is less than 9, that means that 2x minus 3 can be greater than negative 9. Oh, less than, sorry about that, I don't know. Yeah, greater than, I'm right. And 2x minus 3 is less than 9. Okay, so just like before, we just solved both of those. Okay, so 2x minus 3 is greater than negative 9. Just add 3 to both sides. So you have 2x is greater than negative 9 plus 3 is negative 6. Divide both sides by 2. X is greater than negative 3. Okay, so you don't have to flip the sign because you didn't divide by a negative. You only have to flip the sign if you divide or multiply by a negative number. All right. So now if we solve 2x minus 3 is less than 9, we do the same thing. We just add 3 to both sides. So you have 2x, that cancels out, is less than 9 plus 3. It's 12. Divide both sides by 2. You have x is less than 6. Okay, so if we want to put that as just one interval, we can put that as negative 3 is less than x is less than 6. So pretty much x is between negative 3 and 6. Okay, so if we wanted to graph this, you just draw our number line. And we don't have to put in every number. We just have to put in our negative 3 and our 6. And because it's less than and not less than or equal to, you're going to use your parentheses. And it's true for everything in there. I'll just kind of put a 0 here just to hold a space. So every value in here will be true. So if you picked 5, 4, 3, negative 2, any number in there would make that true. All right, any questions on that one? All right. Actually, I'm going to do this next example right up under it because it's really quick. Okay, so what if we wanted to solve, and I'll give you a second to start on this one. 4x minus 5 is less than negative 2. All right, I'll give you a second to start that one. All right, you should be done by now. No, you really should. I'm going to tell you why. Because remember, every absolute value is going to have a positive answer. So there's nowhere in the world the absolute value of anything can be less than -2. So whenever you see the absolute value less than a negative number or less than 0, you automatically know there's no solution. So that's why I was actually able to fit it on that little bitty section. Because there's no solution here. Since the absolute value is always positive, there is no value of x that could make this less than -2. Okay, so your answer is actually just no solution. Okay, so if you wanted to, let's say your solution, I think on these your solution set would be kind of an empty set. No, empty solution set symbol. Alright, so before you get to, if you see that less than the absolute value of something is less than a negative number before you start all the work, just remember that it can never be less than a negative number. Alright, any questions on that one? Alright. Let's do writing. Looks like everyone's done. Alright, so let's say if we, oh, yep, I think I forgot the next one. Yep, I did forget the next one. Okay, so these are solving inequalities in the form absolute value of x is greater than k. Okay, so equal to, less than, and greater than all have different approaches when it comes to absolute values. Okay, so once again, let's say, if we remember, just from the previous ones, let's say absolute value, I'll use a different number, absolute value of -7 just means a distance, well, distance from 0. Absolute value of 7, forgot my equals 7. Sorry about that. Equals 7 just means the distance from 7. I mean distance from 0. Zero is 7. Okay. Nope, actually that should be x. Sorry about that. I'm mixing up my ideas. Okay, so what if we had just before absolute value of x is less than 7? Okay, so remember that means the distance from 0 is less than 7. Okay, so it only stands to reason that if absolute value of x is greater than 7, that means the distance from 0 is greater than 7. Okay, so those are kind of the three options. You have equal to, less than, well, I guess you could say 5 options. You have less than, equal to, greater than, and greater than equal to. But greater than and greater than equal to have the same approach, so there. So this one kind of give you, if you wanted to graph it out, say -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, and we're going to go all the way up to 7. 4, 5, 6, and 7. Okay. And we'll go one more just to kind of run home the point. Probably should have made that number smaller. Okay, so let's go to -8 to 8. Okay, so if we know if the absolute value of 7 means the distance from 0 is greater than 7, then if we're at 0, then that means every number from this side on would be true, because this is greater than a distance from 7, because everything in here is a distance of 7. Oh, should move that over a little bit. Should be over these 7. There we go. And everything here would make this true. That means if you plugged in 6, this wouldn't be true. I mean, -6. Absolute value of -6 is 6. That's not less than 7. If you plugged in -1, absolute value of -1 is 1. That's not greater than 7. But if you plugged in everything past here, it would be true. If you plugged in -8, absolute value of -8 is 8, which is greater than 7. Absolute value of +8 is 8, greater than 7. Absolute value of -100 is 100, which is greater than 7. So any number over here would make it true, and any number here to the right of 7 would make it true. So that means absolute value of x is greater than 7 means that x is less than -7, or, I guess you could say or because it can't be at the same time, x is greater than 7. Okay, so either one of those would make that true. And this has to be or because you can't be in both at the same time. Okay, so if we wanted to write that as kind of a general idea, absolute value of x is greater than k means that x is less than -k or x is greater than k. Or if we wanted to use the greater than or equal to, it would be the same thing. Absolute value of x is greater than or equal to, straighten that out, k, means x is less than or equal to -k or x is greater than or equal to k. All right, any questions on that so far? All right. See, I'm still writing. Looks like everyone's okay. Okay, so let's say